Okay. So it's good morning because I'm in China now, and it's 5 a.m. So I have to get up earlier to give this presentation. So thank you for coming. My name is Boxuan Ma, and our work is each encounter counts, modeling language learning, and forgetting. So language knowledge tracing is important to provide personalized practice contents for each learner and help to schedule repetition practice. However, predicting learners' language knowledge is more difficult because it's related to their forgetting behaviors and temporal information. And also there are different formats even for the same word. For example, like this picture, there are different formats for the same word, providing different levels of information about a particular learner's mastery of a specific word. And finally, there may have cross-effects phenomena in language learning. The cross-effects phenomena indicates the learning of a specific word is not only influenced by previous interactions of the same word, but also previous interactions of other words. For example, practice similar words might influence knowledge. In this work, we first used the real-world English learning dataset to explore the cause effects and the forgetting behavior in language learning based on conditional motor information. We considered four perspectives. First, the same word with different formats, and second, morphologically similar words, and third, thematically related words, and finally, thematically similar words. This page shows the results of our experiments. First, we can see the learner's apparent forgetting behaviors for different situations. And then for cross effects in the same words with different formats, we found that even for the same words, the dependencies are not high for all formats. The cross effects may differ between question formats. Also, we found the dependencies are high within morphologically similar words, which seems to make sense. And those words might have the same prefix or suffix. And the cross effects also exist in semantically related and semantically similar words, especially for the semantically similar words. The dependency are significantly high. And those words may have the same meaning. So it is important to focus not only on previous interactions with the same word, but also we should focus on other related words when for the language tracing modeling. So based on our observations, we developed our model by extending DKT in three aspects. So first, we incorporate the item formats information to boost the model. Here, an item is represented by integrating the word embedding vector and also the item format embedding. In many previous words, you only use target word for the item embedding, but we find it maybe not enough. We also incorporate multiple forgetting related information, so the model can consider forgetting and adapt performance to the learner's forgetting behaviors. So here we have considered different features related to forgetting in our work, including 3 time gap features and 2 interaction features and 1 word features. For time gap features, we have item level time gap, which means the lag time between the current practice and the previous practice with exactly same word. For word level time gap, it is a lag time between the current practice and the previous practice with the same word, maybe in a different format. And the third is sequence time gap, which means the lag time between the current practice and the previous practice. In this case, the word and the format do not matter. For interaction features, we use number of practice and number of corrects, which means number of times the learner practiced the word before and the number of times the learner correctly answered the word before. And also the character length of a word is used as a word feature, since a short word seems easier to remember than a long one. Finally, we utilize the attention mechanism so that the model can track the learner's knowledge state based on not only the same word, but also other related words practiced in the past to adapt cross effects. Here we use pre-trained fast text word embeddings. We use 2 real-world language learning datasets. The first is Duolingo dataset, and then another is Target Mo dataset from Japan. The Duolingo dataset was collected for 2 weeks. It's different languages such as English, French, German, and to compare with Target Mo dataset, we also extracted the English learning logs from the Duolingo dataset as Duolingo EN dataset. The Target Mo dataset was collected for 6 weeks and included 1,900 English words, each with 12 formats. So we evaluate our model and compared it with several existing models. Now here is the results. Overall, our model performs better than other baselines because its models learner forgetting behavior and captures the relationships between items. We also noticed that different kinds of baselines demonstrate noticeable performance gaps. First, performance of the regression-based HAL model is worse than other deep learning-based model for all datasets. In addition, the DKT forget and HuxKT and SAKT show improvement over the basic DKT model, which demonstrates that using temporal information is important in tracing learner language learning and the forgetting processes. Moreover, the dash, lemma, and text, which incorporates linguistic skills of vocabulary items, and performance better than other dash models, which indicates linguistic tags provide important information for modeling vocabulary learning. To gain a deeper understanding of our model, we conduct some ablation experiments. to observe how each part of our model affects performance. First, we observed that performance improves when using more components. And the full model obtained the best performance, and the results revealed that incorporates the forgetting components improves performance, especially in the target mode dataset, which was collected for 6 weeks. And which may mean the memorizing words may be the fundamental aspects of language learning. So forgetting information is important in this task. The attention and item formats are also effective, which is consistent with cross effects. Moreover, we noticed that using word embedding and format to calculate attention score is better than just using word embedding. It can extract not only useful correlations between words, but also between format. Finally, we compared variation of the model using random embedding and the full model using pre-trained word embedding. We observed a significant performance gain when using pre-trained word embeddings, which confirmed that incorporating semantic features based on word embeddings help find semantically related words and effectively boost the model. This result is also constant with the Kress effect phenomena. Next, we looked into the forgetting components to investigate the features related to forgetting. Overall, we find that combining all features was superior to using just one feature for all datasets. And for the targetable dataset, we find the number of practice is the most effective feature, and the number of crack is the second most effective feature. And for Duolingo dataset, each feature seems to improve the performance only slightly. This may be because this dataset was collected only for 2 weeks, and the targetable dataset was collected for 6 weeks. So the forgetting behavior is more distinct and could be captured easily. So benefiting from the attention mechanism, our model can expand the prediction result because visualizing the attention weights can help in understanding which items in past interactions are relevant to the current one. So we visualize our model's attention weights on both data sets. Also, we choose one learner from the targetable data set and use the attention weights corresponding to past interactions to predict his performance on the current item. So, and this figure shows the attention weight is high on items that has same words in the past, even in different format. Also, we find similar words get relatively higher attention weights. This visualization indicates that our model can explain the prediction results and cluster similarity words or similar words or similar formats. Okay, for the conclusion. In this paper, we first explored the cross effects and the forgetting behaviors in language learning from different perspectives. And based on our observations, we proposed a method for language knowledge tracing, consider different formats and learners forgetting behaviors, and also the item correlations. Experimental results on two real-world language learning datasets shows our model outperformance than other than other baselines, and it could explain the prediction results based on attention rates. And for future work, we plan to incorporate morphological features into the model, and also it is of interest to investigate the influence of different question formats for vocabulary learning. Thank you for your attention. So, glad to answer any questions. Yeah.
Okay, wonderful. Thank you so much for that presentation. I'm going to ask one of the questions that's being asked in HOVA, and then if anyone has a question in the room. The question we have online in HOVA is it possible to understand what features are captured by a learner over time, whereas others are forgotten? In other words, can you look at whether a user is remembering vocabulary and meaning, but perhaps not contextual usage?
Thank you for your question. So for now, we find actually it's difficult to modeling the learners who learning and forgetting process, but it's of interest to find different questions for vocabulary, and different question formats may assess different skills, so which may be different. For example, some question may assess reading skills, and others for speaking, or others for just the meaning of the vocabulary. So we are still trying to work this up in our future work. Thank you.